Welcome back to the NT podcast, where we explore the deepest questions at the intersection of philosophy, science, and religion. I'm your host, Nemanja Jurišić, and today we are joined by one of the world's leading philosophers of religion, Dr. Graham Oppy, to discuss one of the most fascinating and controversial topics in contemporary metaphysics, infinity. What should we make of famous paradoxes such as Hilbert's Hotel, the Grim Reaper, Thomson's Lamp, and many more? Professor Oppy, welcome. How are you?
Thanks for inviting me. I'm looking forward to the discussion.
Thank you for coming to my channel for the third time. We talked on arguments for theism, then about coherence of theism. But if there is even a chance that there is a God, then we want to say that he is infinite in power, knowledge, goodness, etc. But what if that's not even possible? So first of all, can you answer, is it possible for God to be infinite in power, knowledge, and other things?
Okay, that's a really difficult question. We might start with an easier question. So what sorts of infinities could there be or are there before we worry about exactly what it might mean to say that you've got infinite power or infinite knowledge or something like that? So could there be infinitely many stars in the universe? That seems like a good question. And I'm kind of undecided about what to think about that. So we have a bound on the size of the universe. We know it's no smaller than a certain amount, but I don't think we know how big it is. So I don't think that we've got evidence from the sciences that tells us definitively that there aren't infinitely many stars. On the other hand, I reckon if I was required to bet on it, I would bet that the number of stars is finite, that the universe is finite in spatial extent. But, as you said at the beginning, these questions are contentious and endlessly debated. And part of the difficulty that we face when we're asking a question like that one, which sounds like it's a fine question, are there infinitely many stars? We just have no idea how we go about finding out that the answer was yes.
Right, Professor Opie, but maybe some philosophers would argue that distance is potentially infinitely divisible. So is it possible, or is it just appearance? Maybe Zeno paradox is also crucial for this discussion. So could you explain that as well?
So obviously physics and the sciences raise their head here as well. So there's a question about, as you just mentioned, about the structure of space. And since the first formulations of quantum mechanics, there have been lots of people who've wondered whether space-time is discrete, and they've tried to come up with models that would make space-time discrete, on which there's a kind of minimum spatiotemporal extent, right? And there can't be anything smaller than that. So some people talk about the Planck length as being the kind of fundamental minimum length. If it's true that space-time is discrete, and if it's also true that the universe is finite, then you won't get any infinities out of this, right? Unless you think that there's an infinite history, or, going one way or the other, an infinite past and or an infinite future. So if you think that the past is finite, and there are lots of people who think that maybe the universe began with a Big Bang, maybe there's nothing else apart from this universe. There's still this question about the future, right? The physics sort of suggests, I think, that the universe is going to go on expanding. It's just going to go on doing that forever. And so in that sense, you do get an infinity. It's not that at any particular time It will be true that there's an infinite history prior to that time, but if you think about the universe as a whole and you ask, so what's the kind of measure on its size thought of as a four-dimensional entity, the answer is going to be that it's infinite, just because the future's unbounded. Okay, so that was a question about, you started with a question about the infinite divisibility of space and time. So we've talked about the kind of extent in the large and in the small of space. If it turned out that space and time were discrete and finite, then I think it would turn out that there wasn't anything in the physical world that was infinite. Right? But I suspect that's not how it turns out, because I think the future's probably infinite. On the other hand, the question about the divisibility, I just have an open mind about that. It's quite hard to make sense of having a discrete space-time. So one of the things that turned out in the history of quantum mechanics was that people kept trying to make these models, and the models were kind of internally unsatisfactory. So it's quite hard. It turned out to be quite hard to make a model of a discrete space-time, but I think that eventually people, if it hasn't already been done, I haven't really kept up on recent developments in the philosophy of space and time. If it hasn't already been done, I assume at some point it'll be possible to make those models, but there'll still be this question whether, what the world's really like.
Yeah, if I correctly understood you, you want to let scientists to decide whether it's possible or probable or anything, rather than to put philosophical arguments that there is infinite universe or divisibility or anything. Is that correct?
So there are other questions, right? So that was just kind of a question about how things actually are. There's a different question, not about the kind of doxastic possibility, because we kind of don't know, but rather kind of metaphysical possibility. And it depends a lot on how you think about metaphysical possibility at this point, because it certainly seems that we can make models of worlds that are infinite in all kinds of ways, infinite in the past, infinite in the future, infinite in the small, infinite in the large, right? And these models are not logically inconsistent, and they don't seem to violate any conditions on the meanings of terms that we use. Like they're not, as some people would say, analytically false either, right? So, and those questions, it's not so clear that those are questions for science, right? The questions about what's possible. It looks like those are going to, if we're going to answer those questions, we're going to answer them using philosophical means.
Thank you for clarification. So some philosophers thinks that problems with completing an infinite task are problem for those who believe that there are actual infinities. So can someone complete an infinite task? Could someone climb out of a bottomless pit, etc.? So Ryan Mullins put like this, imagine that we pause the universe at this moment and ask, how many days occur before this one? 1, 2, 3, and so on backwards. If we continue counting backwards, we will never reach infinity, because infinity cannot be attained by successive addition or subtraction. Since we live in time that is constantly being added, one may conclude that the past is probably not infinite. What do you think on this?
So, if you think about the starting today and counting backwards, so yesterday is 1, and the day before that is 2, and so on, and counting back. It's true that there's no infinitieth day. There's no day that's going to get the number infinity attached to it. In fact, infinity isn't one of the natural numbers. If it's a number at all, it's a number in a special sense. But that doesn't mean that the past isn't infinite. All that's required for that is that for every number, there's a day that corresponds to it, right? So the counting backwards doesn't show that the thought experiment that we just conducted tells us nothing about whether the past's actually infinite or not, right? I mean, it's if you take it in the other direction and think about counting forwards, 1, 2, 3, 4, 5, at any day, there will only have been infinitely many days since the present. That's one question, but a different question is how many days are there in total in the future? And if there's one for every number, then that's all it takes to make it that the future's infinite and actually infinite, right? So, so I'm not really impressed by that kind of attempt to argue that probably the past is finite. I'll just add a little caveat at this point. If I had to bet, I guess I'd be inclined to bet that the past is finite, but not with any confidence. And the past here might not just be our universe. There might be a multiverse, and there might be a kind of infinite past in the multiverse, even if there isn't one in our universe. And so I just think we don't have enough reason to say that we can definitively answer this question about whether the past is infinite or not. But if you make me pick, for reasons that we might talk about, I'll vote for finite.
Yes, in previous interview you said that it's cheaper to believe in finite past, but it's not clear. But why do you think that there are many less assumptions in finite
So,
universe?
so there's a question about various things. So trade-offs that you're going to make. So one, if you think that there's an infinite past, you've committed to an awful lot of stuff, right? If you think that there's a finite past, you commit to a lot less. Either way, I think, if you want an answer to the question, why is there something rather than nothing, you're going to have to postulate that something's necessary. So either the starting point or either you're going to have to say it's necessary, there's a necessary starting point, or you're going to have to say it was necessary that there was some part of the history, though there's no part of the history that's necessary, but it was necessary that there was some of it. And then you've got an explanation of why there's something rather than nothing. Right. Now, you might think that you could just suppose there's no answer to this question, why is there something rather than nothing, is just kind of brute happenstance or something like that. And so I'm not saying that you have to choose between necessary beginning or it was necessary that there was some part of the history, even though no particular part of it's necessary. But those seem to me to be the two more attractive options.
I wonder what other philosophers and scientists, mathematicians think on this topic. Is there any consensus or a survey about whether actual infinity is metaphysically impossible or logically impossible? Is there anything to say?
So I'm not sure that there's surveys about it, and part of what makes it difficult is that scientists are usually not interested in the philosophical question. They just want to make a model of the universe, right? They're not interested in what's possible in a metaphysical sense. Because of their ignorance, they're interested in what's possible in a kind of doxastic sense, what's consistent with the data or something like that. But when the philosopher gives an answer about what's or takes a position about what's metaphysically necessary, they may rule impossible lots of things that are amongst the current models that physicists take seriously, right? There's just two different questions going on here.
Okay, thank you. So what about future? Is future actual or potential infinite, or will there be some absolute end? And does that pose a problem for theists or Christians who think that actual infinities aren't possible?
Okay, so I read a really nice book in the 90s. I forget who the authors were about the future of from the standpoint of physics, what the likely future of the universe is. And their view then, and I'm not sure that this has changed, was that the universe will just go on expanding slowly. If you think about what's happening in the universe at about, I think about 10 to the 40 years from now, protons will decay. At about 10 to the 150 years from now, the last enormous black hole will decay by Hawking radiation, and the universe will be sort of cold and dark and empty, but it will keep on expanding. And so it has an infinite future. The other speculative option, so I think more speculative option, is that at a certain point the expansion will stop and the universe will start collapsing in on itself. And if it went that way, assuming that you don't have a kind of series of bounces, if it's just sort of one expansion and one contraction, then the whole history turns out to be finite. Does that make a problem for religious believers? Well, it does if they think that the life to come is going to be on Earth, right? But there's a whole lot of other stuff in that physics, like proton decay, for example. That means that there isn't going to be an infinite future of life on Earth. The Earth, I mean, in fact, we can bring it back in much shorter than that. Within 6 billion years, the sun will go red giant and the Earth will be incinerated, burned to a crisp, right? There's no eternal future for the Earth.
Okay, and let's say if there is a God, an afterlife, and the scenario from the Bible, can we say is it actual or potential infinite? Because Christians would like to distinct those. Yeah.
Right. So I'm thinking that from a metaphysical point of view, this distinction really isn't interesting. Um, if I mean, to go back to just talking of pretending that the Earth's going to last forever, we're going to have day after day after day, right? So long as each day is followed by another day, that means the future's infinite, right? It doesn't mean there'll be some point at which an infinite amount of time has elapsed, assuming that there was an origin, say 13.82 billion years ago, or whatever, right? But it does mean that now, I mean, this thing about the distinction between actual and merely potential infinities goes back to Aristotle. And there were lots of people who somehow had this view that there was an important distinction here, and you could have potential infinities, but you couldn't have actual infinities. And that strikes me as quite odd, right? And in particular, in connection with space, it's not clear what it would mean to say in the large that space is merely potentially infinite, right? Because at any given point in time, I'm going to think in Newtonian terms, right? There's space is what it is, right? And so it could be, for all we know, that there are infinitely many stars dotted around. Well, actually, they won't be dotted around because they collect into galaxies and the galaxies collect into bigger structures and so on. But at any rate, it's hard to see that there's any sense in which the distinction between actual infinity and potential infinity applies when we're asking questions like that one. right? Because that's just a question about what the world's like right now.
Great. Are there any other sorts of infinities to mention? Because I studied math and we have, I don't know how to translate, is it bigger and lesser, greater and lesser infinities? Or, yeah.
Okay, so there's this other question because people have been interested in the mathematics of infinity for a very long time. And there were, so Archimedes and some of the other early Greek mathematicians essentially had methods for solving certain sorts of problems that involved allowing certain quantities to go off to infinity. Right. So an idea that's kind of familiar to people who've done high school maths in calculus. Right. So you have these a series like the series a half, a third, a quarter, a fifth, a sixth, a seventh. So it's 1 over n. You let n go to infinity, the limit of the series is 0. Right, that's the and that you can use fairly simple mathematics to show that the limit for that series as n goes to infinity is 0. So mathematicians over the centuries have developed, I think, a very rich theory of mathematical infinities, which is what you're referring to. So start with the natural numbers. How many of them are there? Well, there's a cardinality to them that way back when would have been what people thought of as infinity, right? Mathematicians call it Aleph null these days. So, and there's a question about whether there are smaller infinities than Aleph null, but the kind of standard view, I think, is no, it's the smallest one. Then there's infinities that are bigger. So if you think about the natural numbers, and then you think about the even numbers, you can pair them up 1 to 1, map 1 to 2, 2 to 4, 3 to 6, 4 to 8, and so on. So there's the same infinite number of even numbers as there are of natural numbers in general. And we can do a similar mapping for prime numbers because now I forget who it was, probably Euclid, proved that for any number of primes, there's another one, right? So there's infinitely many primes, so you can map them up, map 1 to the first prime, 2 to the second, and so on. There's just as many prime numbers as there are natural numbers. So what about the real numbers? Well, this is one of the famous things that Cantor proved. You can't put the real numbers into 1-1 correspondence with the natural numbers. There are more real numbers than there are natural numbers. And so the cardinality of the natural of the reals we call C, and there's a question about whether C is Aleph1 or not, whether it's the next Aleph after Aleph0. But once we've got that far, there's a kind of infinite series of cardinalities, each bigger than the next. And that whole the structure that you get there, you can think of as being part of what Wittgenstein referred to as Cantor's paradise, right, for mathematicians. But basically, set theory kind of is the theory in which you elaborate, or in which you can elaborate this kind of full account of infinite cardinals.
Thank you, Professor Oppy. So perhaps we should done this at the beginning about your book. So before we start with paradoxes, can you just tell us about your great book that you wrote from Cambridge Press, Philosophical Perspectives on Infinity? Could you tell us what is the background of that book? And maybe why to study even infinity? That's a good question, I think.
Okay, so I forget which year it was, about 1997 or 1996, I taught an honours class at Monash. And so the class was metaphysics. And the year before, I'd taught about truth. Actually, I think no, it must have been later. It might have even been 1999. Anyway, then the next couple of years, I talked about properties, and I decided I'd talk about infinity. And I wrote up very extensive notes for each of the classes, and that was the genesis of the book. The book is essentially just a set of lecture notes from a class that I taught. And so it covers a range of questions. So one of the things that I spend quite a lot of time on is a bunch of paradoxes, philosophical paradoxes about the infinite that you mentioned in the beginning, things like the Thomson lamp and Grim Reaper paradox and so on. But I talk about infinity and sort of paradoxes of infinity in connection with space and time, which we've already sort of touched on. There's connection there to Kant because the antinomies in the Critique of Pure Reason argue that, for example, there's a solid argument that space is finite and that it's infinite and so on. I talk about infinities in science, in decision theory, and in a range of other topics. So there's stuff about Pascal's wager, for example, which deals in infinite utilities. So that's kind of another way in which questions about infinity come into philosophy of religion.
Very good. There is one more very important book for our interview, also from Jose Bernadette, Infinity, an Essay in Metaphysics. So, what do you think of this book?
Yeah, it's a great and underappreciated book, I think. I was very lucky when I came to Monash. John Bigelow lent me his copy of the book and said, read this book, you'll like it. And I read it, and indeed I did. It's got lots of really interesting ideas in it.
Okay, let's talk about paradoxes. So, first one is Hilbert's Hotel. Can you explain it? And what do you think of what are implications?
Okay, so suppose that we've got an infinite hotel. So we'll imagine that there's an infinite plane heading off into the distance, and we're at the reception of the hotel. And then there's a bunch of rooms. We'll imagine that it's a very long, thin corridor, right? A bunch of rooms numbered 1, 2, 3, 4, and it goes off to infinity, right? So it's a hotel with infinitely many rooms. And we imagine that the hotel's full, so there's someone in every room. And someone turns up at reception and says, can you give me a room for the night? And the clerk says, no problems. And so he makes an announcement that goes out to everybody saying, you must move up one room. So the person in room 1 goes to room 2, the person in room 2 goes to room 3, and so on. And then you put the new guest into room 1. So the hotel was full, but there was room to add an extra person to it. That might sound to you like it's absurd or contradictory or something like that, right? And that's just the beginning of what's interesting about this. So suppose that infinitely many people turn up at reception. And so now the announcement that the clerk makes is everybody is to move to the room that's double the room that where the number's double the one that they're currently in. So 1 goes to 2, 2 goes to 4, 3 goes to 6. And then the infinitely many people get put into the odd numbered rooms, 1, 3, 5, 7, 9. So the hotel was full, but it could still accommodate infinitely many people. Right? And that might seem disturbing as well. So that's the basic setup for Hilbert's Hotel. Some people think that somehow or other the stories are absurd, and that shows that there couldn't possibly be actual infinities, right? Some people think that the story is impossible for other reasons. So go back to the situation where we've got the clerk and the one person has turned up to the hotel. Right? If messages travel at a finite speed, then there's no way that the clerk can tell all the people in all the rooms to move up in a way that's so imagine, right, imagine that the signal can only travel at the speed of light. Right? There'll be no problem about getting the new person in and shifting the person from room 1 to room 2 and the one from room 2 to room 3. But way down the other end, the message isn't going to get there until those people have checked out or they're dead or something like that, right? Because of the finite signaling time. And you might think that there really is a problem about infinite signaling, right? And that problem about infinite signals, infinite speed of transmission of signals, means that the story that's being told here is not going to be a realistic story, whether or not there could be a hotel with infinitely many rooms.
Yes, and those paradoxes maybe have a root even in Al-Ghazali's paradox about planets in solar system. So is that maybe good paradox, or is it?
So I think that Al-Ghazali was very clever to come up with the paradox. I don't know that it's original to him, and it's a kind of paradox that keeps getting either people know about it or they rediscover it in the subsequent centuries. So if we think about the Earth and Jupiter, and I've got no idea what the ratio of the amount of time that it takes Earth to make one lap of the sun and Jupiter to make one lap of the sun, what that ratio is. But let's suppose that Earth does 9 laps to Jupiter's 1. And then we suppose that the past is infinite, and we ask, so which planet has made more laps of the sun? Al-Ghazali
I'm
says,
sorry,
well,
can I just add? It's 12 Earth years. So if you want to put a real number, yeah, I found that. Yeah.
so it's 12, you said. Yeah. I'll stick with, okay, well, I'll move to 12. Right. So and then we ask which planet has made the most orbits of the sun? And Al-Ghazali says if the past is infinite, then they've both made infinitely many orbits, so they've made the same number. And yet, for every time that Jupiter goes around, the Earth goes around 12 times, right? So that's absurd. The right conclusion to draw, in his view, is that the past can't be infinite. I think that this puzzle is pretty easily resolved just by drawing a distinction between two different ways of understanding the question about how many revolutions the two things have made. So on the one hand, if you're asking about the cardinality, then the cardinality of the number of revolutions is the same, right? They both made aleph null revolutions or orbits. And that's on its own, that's not particularly paradoxical. It's no worse than thinking that there are just as many numbers as there are prime numbers, right? Once we've got infinite collections, you just get this. On the other hand, if you ask, okay, let's consider after 12 years, the Earth's made 12 orbits and Jupiter's made one. After 24 years, the Earth's made 24 orbits and Jupiter's made 2. After 36 years, Jupiter's made 3 orbits, the Earth's made 36. So we've got a ratio here. If we're counting up the orbits, if Jupiter's made n orbits, the Earth's made 13 n orbits, the ratio of the orbits is 13, right? And then we take the limit of the series, the limit is still 13. So the Earth makes 13 times as many orbits as Jupiter does, even if time's infinite. It doesn't matter whether time's finite or infinite. In this sense, right, the Earth's making more revolutions. That's not to contradict the sense in which the cardinality of the number of the orbits is the same. It's just to point out that there are two different things that we're talking about here. And the kind of mistake that Al-Ghazali is making is in not recognizing that there are these two different senses that apply, that two different ways of answering the question, how many?
Right, and next variant is paradox of infinite library. So is it maybe better variant of Hilbert's hotel or something like
So
that?
I think it's just a variant of Hilbert's hotel. I don't think that it raises any new issues. You have the same questions about whether, holding fixed enough of the actual world's physics, right? The operations of the library are impossible. And if you think, as some people do, that the kind of actual world physics, whatever it is necessary, then that will just rule the library impossible. That doesn't answer the question about whether there are other sorts of infinities that are possible. It's just that there are features of the library, just as there are features of the hotel that rely on things like sending signals. And if you assume that signal speeds are finite, then you get difficulties for those stories.
All right, Dr. Oppy, and now here is a paradox. I found this in a book by Andrew Locke. He says a piece of paper is passed down from the past to the present, from person to person. If it is blank, someone would write his unique name on it. If it is not blank, it is simply passed on. Suppose the past is infinite. When the paper reaches you, what is written? Something must have been written by then, yet nothing could have been written because any name that might have been written would have been a different name. That is the name of the person before. Does it
Right.
show maybe
So,
that,
so this is just a version of the famous Benedetti paradox. It's a version of the Reaper paradox. Right. We've set up two conditions, right, that are jointly not satisfiable, right? Because we want to have that there's this condition that someone will write just so long as no one else has done so before. Right. That's one of the conditions. And the second condition is that there's no there's no initial state, right? So we have an infinite. If you've got a kind of infinite past, you can't satisfy that condition, the kind of nothing but condition. So the scenario, as he's describing it, is impossible, but that's not something that shows that an infinite past is impossible. It's what it shows is that if you suppose that there can be an infinite past, you're going to suppose that there just can't be things that satisfy that particular condition. Right, so to go to the version in the Grim Reapers, there's a person who's been targeted by the mob, an infinite mob, and each of the members of the mob is assigned a time at which they're to kill him if he's still alive. So the first Reaper gets 11 o'clock, the next one gets 10:30, the next one gets 10:15, the next one gets 10:08.5, and so on. But nobody gets assigned 10 o'clock. And then you ask, so what happens to the victim? Right, well, if he's still alive at 10:30, he's going to be killed at 11. Right? But he won't be alive at 10:30 because had he been alive at 10, he would have been killed. Sorry, at 10:15, he would have been killed at 10:30. Right? It has the same structure as the thing you're thinking of. And so it turns out that none of the Reapers can kill him because for each they're too late. There's an earlier one that would have done it. The right thing to conclude is that you just can't have this setup, right? But that nothing follows from that about whether time's infinitely divisible or not.
So what are the implications? Because proponents of causal finitism wants to say that if infinities are possible, then this scenario should be possible. But it's impossible, so causal finitism is true. So how would you comment?
So one thing that people will say is contradictions are impossible, right? And you just provided you just gave two conditions that are jointly unsatisfiable. So of course they're not satisfiable. That doesn't show anything about the satisfiability of the conditions separately, right? And what we were interested in is, could there be an infinite past? Now, there are arguments. So Alex Proust has arguments which are supposed to show that that if the Reaper scenario was possible, it could be generated by things that are clearly okay. So think about an example like this. We'll take the Reaper scenario, but put someone in at 10 o'clock who kills the man, right? Kills the victim. Now, none of the other Reapers do anything and there's no contradiction, right? So you might think that if you're a friend of infinity, you're going to suppose that's possible, right? You could line up all of these Reapers, you could have the one at 10 o'clock kill the victim, and then all the others, infinitely many of them, getting closer and closer back to 10 o'clock, don't do anything. Okay, so suppose that's possible. Suppose it is possible that you've got that, because there's no you don't have any inconsistency in that story involving infinity. Now imagine that we do something to we have the same setup, right? They're set up just the same, but we do something to the guy at 10 o'clock so that he doesn't act. Now what happens? Well, now we're just back to the original scenario, and that's impossible, right? But surely if it was possible to have the Reapers with the one at 10 o'clock, we could then do something to the one at 10 o'clock, right, without disturbing the possibility of the scenario, and yet we would end up in contradiction. So Proust thinks, I mean, I'm simplifying and not including all the bells and whistles. So he thinks what follows from this is that you can't have an infinite series of causal dependencies, right? That's what the causal finitism is, where what each thing does is causally dependent on the thing before. So he thinks that's the best way to respond. I'm inclined to think something a bit different from that. So if we think about the reapers, so each reaper we're imagining has a certain disposition that they're going to kill the person if they're alive, and otherwise they're going to do nothing. So each of the reapers has this disposition, including the one at 10 o'clock. And the one at 10 o'clock, the guy's still alive, so the reaper at 10 o'clock kills him. And it's supposed to be that this disposition governs what the reapers do in any possible circumstances in which you place them. Right? But suppose you think that it's possible to line them up in this way with the one at 10 o'clock that kills and all the rest of them don't, and that it's possible to subtract the one at 10 o'clock. Right? Well, now the dispositions of the reapers, the dispositions that we've attributed to them, don't determine what they do. There's got to be something that things do in those circumstances. But we already saw that if their disposition is merely to kill if it's still alive, then there's no answer to the question what they do. So one way of responding to Proust is to say that he didn't specify the conditions of the dispositions properly. Right? If you really think that it's possible that there be this infinite causal series, then you've got to suppose that the disposition's more complicated than he allows, so that you get them consistently doing something. Right? So let's change the example. Make it an infinite array of light globes. Right? And there's an initial one, and if it's on, all the rest of them are off. Right? But each of them has this disposition that it will be on so long as the one next to it is, sorry, it'll be off so long as the one next to it is on. And sort of if and only if. It'll be off if and only if. Right? Take away the initial light globe, right? And then there's no saying, right? With that disposition, we just don't get a specification of what the light globes do. But we can add that the kind of ground state for the light globes is that they flicker. So if unless they get the right kind of circumstances to move them into an on or an off state, they'll just flicker. And now we know what happens. You take the initial light globe away and all the rest of them just flicker. Now we have a consistent story again. We've just complicated their disposition. Right? Now, it was an important part of the story that Proust was telling, that it was possible for things to have the simple disposition, right? The simple disposition, the way he described it. And I agree with him that if you could have things with that simple disposition and you could put them into, causal finitism is false, you can put them into the right kind of causal relationship to one another, you're just going to get rubbish, contradiction out, right? But rather than, but you have two options here. You can either blame the assumption of causal infinitism, or you can blame the account that's given of the dispositions of the various things. So if you believe in causal infinitism, which I'm not sure that I do, right? But if I did, I would say, no, when you thought you were describing possible things and you assigned these dispositions to them, you were not actually succeeding in describing possible things at all, because the dispositions have to determine what a thing does in all the circumstances in which it can be placed. And if it can be placed in infinite arrays, there's got to be an answer to the question, what does it do in those circumstances? So here's a kind of simple example of the same kind of thing. Maybe this will be persuasive, maybe it won't. So suppose you've got two light globes, right, that are opposite each other. And one of the light globes is set up so that it will be on just in case the other one is off. But the other light globe is set up so that it'll be on just in case the other one is on. Right? So you've got these two light globes, and that's how they're related to one another. So when you turn the power on, what happens? Right? It can't be. Neither of them can realize its disposition. Right? In that case, plausibly, what's going to happen is they're both going to flicker backwards and forwards, because each of them one of them's trying to match the state of the other, and the other's trying to be in the opposite state, right? So the idea that you could have two light globes with those dispositions and you could connect them and they would realize their dispositions is absurd. But there's not a problem about infinity. There's only two of them. We're not going to conclude that causal finitism is impossible, right? So that's what I want to say in response to the Bruce argument, right? That we have two options, right? And while he's convinced that we can take for granted that it's possible that there are things that have very simple causal dispositions, I want to say that's only going to be true if those things can only occur in worlds with where causal finitism is true. If those things can appear in worlds where causal infinitism is false, then they can't have those simple dispositions. Anyway, there it is. That's what I think.
Incredible answer. Really deep and challenging, I think, for causal finitists. So great. And are there any variants that are important to mention, even because Bruce likes more to talk about orange placer paradox? That's maybe a less violent version of Grimm paradox. So do you want to mention any other variant?
Not really. So the scenarios that Bruce describes are more or less as I just gave them. You start off with the original Grim Reaper, you then imagine modifying it, which you can do in various ways, but one of the simplest ways is just to put an extra Reaper at the beginning, right? And the story can be, Koons also does this. You can make it not be about murder. You can make it about whatever you like. That's why I shifted to light globes being on and off, by the way, because there's nothing violent about that. And then you can imagine telling a story about things that seem obviously possible that lead to the disabling of the prefixing, the initial Reaper, the one that was, once you take it away, you just get back to the original Grim Reaper paradox. And I don't think that I've left anything important out from the way that Bruce is responding to trying to make an argument for causal finitism from the Grim Reaper paradox.
Good. So there are people that like to combine other paradoxes with Grim Reaper. So, for example, we have Josh Rasmussen. He wants to combine liar paradox with Grim Reaper. So he says, quote, "Let the sentence S be, there has never been a true sentence. S is clearly false, since there have been true sentences. But now imagine that every day from eternity past, a new copy of S is created. Suppose there are the only sentences that ever exist. Is any copy of S true? Well, one is true if and only if none are true. That's a contradiction." How would you comment this?
So this is a paradox that's due to Yablo originally. So this is Yablo's paradox. And it's an interesting question what to say about Yablo's paradox. I don't think that, I mean, it's not a paradox about causation, though. It's a paradox of really just in philosophy of language. And I have to admit, I don't have a good enough grasp on the current state of the literature to know exactly what to say about that paradox.
Okay, and Dr. Oppy, we have an article from Ibrahim Daher. Its title is An Incredibly Good Argument for Causal Finitism. So he combines Grim Reaper paradox with the grandfather paradox, time travel and other things. So is that a good argument for causal finitism? Do you know the article?
So I've heard of the article, I haven't read it, and I'm not sure how the argument goes. So I'm thinking that there's no particular reason why, whether if you're an infinitist, you have to think that time travel is possible. You might just think that time travel is impossible. And so it's not clear to me how we're going to, I mean, maybe you've read the article and you know what to say, but it's not clear to me how we're going to get support for causal finitism out of this. And it's also the case, as I said before, that you can think that the Grim Reaper arrangement's impossible, that you can't have infinitely many agents sort of packed into an area so that they can all act on a particular thing in a finite amount of time, while still thinking that the past is infinite. So, and thinking that there are kind of causal dependencies. So maybe the state of, so what's an example? I wanted that you have an infinite series of generations, and the existence of each generation is causally dependent on the one before, but it just goes back forever. It's not clear that there's any contradiction in that. It's not clear that you can't hold that that's possible while still holding that the kinds of arrangements that you need for Hilbert's Hotel or the Grim Reaper paradox are impossible. And so it's hard. I find it quite hard to see how, when if I'm somebody who says the hotel's impossible, the Grim Reapers are impossible, but nonetheless, I think that there could be an infinite series of generations. How an argument from the hotel or the Grim Reaper is going to persuade me that causal infinitism is false. The causal finitism is true. I just don't see that.
Yeah, what if we say instead of it's false, it's just not the case? For example, we can say it's not logically possible to travel through time. Maybe some astrophysicists, I think Neil deGrasse Tyson would say, we just don't have a technology to do that. But theoretically, it's possible if we manage some speed bigger than speed of light. So if we compare that with the Grim Reaper, we could say infinite past is possible, but for some reason it's not the case. So what do you think about that?
So I'm inclined to think that you'll get a better theory if you don't say that, but I can't deny that there have been lots of publications in physics over the last 50 years speculating about time travel, whether it's possible to send a particle back in time, even if only a little bit, send something back in time a few minutes or something like that. And I'm not a physicist. I don't know what the what the current thinking of people who work in quantum mechanics is.
Yes, but as a philosopher, this is a good time to cover this question. You can tell us, is it metaphysically or logically possible to have closed cyclical loops to exist? Is it possible that A causes B causes C causes A again? You wrote something about that, so
Yeah, so if so I'll go back to one of the things that I said before. If you're thinking that kind of consistent conceivability is the kind of touchstone for possibility, then I think then you're going to think that all kinds of things are possible that don't actually happen, right? If time travel into the past was discontinuous time travel into the past was possible. So you get into your time machine, you push a button, and then you just appear back in the past at some point. Then, from the standpoint of observers at the time, there'll be things just popping into existence, right? All of a sudden, there'll be this man in a machine that materializes in 1931 or whatever. That's how it will have seemed to the people in 1931. If you don't think that things can just kind of materialize in thin air like that, you're not going to think that this kind of time travel into the past is possible. Um, in some sense. But the conceivability of this seems straightforward, right? There are kind of coherent time travel fictions that have been written, so long as you're prepared to accept um, the um, the assumption, right, that you can make discontinuous travel into the past. You can build fictional possible worlds around that that don't contain any contradictions. On the other hand, so that was one way of thinking about metaphysical possibility in terms of conceivability. On the other hand, if you take a much more kind of actualist view and think that possibilities have to be grounded in how the world actually is, so what possibilities there are fully determined by how the world actually is. You might think that if there's no time travel to the past, then it's just impossible that there's time travel to the past, and so on. Right? There's nothing in actuality that could ground time travel to the past. That's a view that you might have. That's the kind of view of modality that I prefer. I think that it's kind of extravagant to think that that just sort of fantasizing about things somehow connects to reality in an important sense.
Okay, Dr. Oppy, thank you. So we have just a few questions. What about Methuselah's diary paradox? Locke mentioned this one of the five arguments that he lists, but he says if one of those five is correct, so infinite regress is impossible. So, would
Okay, so how does the diary go? Is this like the Tristram Shandy paradox, where Tristram Shandy records, sort of plans out each day before it happens, but it takes him a year to plan a day? So we imagine that on the 1st of January 1990, he sets out to plan what he's going to be doing on the 31st of December of that year. And then the previous year, he planned what he was going to be doing on the 30th of December. And then the year before that, he planned what he was going to be doing on the 29th of December. And so we're to imagine that Methuselah gets to a certain point and puts down his pen and says, I'm done. I've planned my life up to that point. Right. Is that the structure of Methuselah's diary?
Yeah, that's it. Yeah.
Yeah. Right. So this is actually a paradox that Bertrand Russell devised. If I'm remembering it correctly. Right. Now, there's a problem. The story's just incoherent. That story is just incoherent. And so nothing interesting is going to follow. Okay.
Okay, thank you. What about Thomson's lamp? Even Bruce says this is only a warm up when he give a lecture, so he doesn't think this is really a strong argument. But can you comment?
So Thomson considered having a switch to turn a light on and off, and imagined turning the switch faster and faster and faster, so that the light, so we'll go back to our 10 o'clock and 11 o'clock. The light's on at 10, off at 10:30, on at 10:45, off at 10:53 and a half, and so on. And then there's a question, okay, so what's the state of the lamp at 11 o'clock? Because it goes off, on, pick any point before 11, and there'll be an answer, but there'll be more switching, in fact, infinitely more switching to happen before we get to 11 o'clock. Right, so it looks as though I've fully specified the scenario, but you just can't answer the question whether the light will be on or off at 11 o'clock. That's roughly the Thomson's lamp paradox. I kind of like what Benalla said about this, right? There's a lot of detail in this, and Grunbaum subsequently. There's a lot of detail in the story that hasn't been specified. So let's imagine that we've got a switch, and we're displacing it less and less and less. And when the switch comes to rest, the circuit's going to be closed and the light's going to be on, right? So we imagine going through this thing, flicking on and off, but smaller and smaller and smaller. We get to 11 o'clock and the light's on because I just specified what the answer would be. Thomson didn't say. I could have specified it differently. I could have said when it gets to 0, the circuit's broken and the lamp's off, right? That's also a possible continuation of the story, right? I told the story this way to remove what would otherwise have been an objectionable infinity, that the switch would have been moving infinitely fast when we got to 11 o'clock. And you might think, nothing can go faster than light, so the switch can't, so that would be objectionable. But in this case, I had the displacement of the switch converging to 0 as we got closer to the time. So the kind of any worries that you might have about the story seem to be dissipated. But you also get an answer, right? Because you've filled in the extra information that's missing. I think if this is analogous to what I wanted to do with the Grim Reapers, you didn't specify enough about their dispositions. Once you do, you know exactly what happens, right? So I'm thinking that Benalla move is a good one to make. I mean, if you tell a story, you don't give enough detail, and then you say you can't work out what happens, so causal finitism is true. There's obviously something that's gone wrong with that argumentative procedure, right? So
Yes, and
that's the kind of point that Grunbaum made in a bunch of publications in the 60s. He was very interested in giving consistent descriptions of the Thomson lamp where there were no infinities other than the one of there's an infinite amount of switching, but no other infinities in it.
And many philosophers are intrigued with this because those are just imaginary scenarios and doesn't need to have any connection with the actual world and things that really exist. So nobody thinks that there is a Thomson's lamp, infinite hotel. So how to connect those two? Is it even possible?
So I'm very sure there couldn't be an infinite hotel, right? So here's why, because I think that every possible world shares some history with the actual world and diverges from it because chances play out differently. So there's only quite a narrow range of possibilities. And there's hotels are built by creatures like us on planets like ours that are finite. There's nowhere and no when that an infinite hotel could be built. So it's impossible that there's an infinite hotel. I'm quite happy with that conclusion. Right? That's because I have quite a constrained view about what's possible, but that seems fine to me. I'm going to say the same thing about the Thomson lamp, right? It's outright impossible. There couldn't be anything like that, right? And the problem is going to be with actual world physics that the displacement of the switch can't go to zero in this way without the kind of fluctuations in the current being dominated by just sort of quantum randomness or something like that. Right? The Thomson lamp really relies on a kind of very precise kind of Newtonian physics and just doesn't fit with actual world physics. And so I think it's impossible also. And in fact, and this is part, I spent quite a bit of the relevant chapter in the book on infinity thinking about this. There are very few of the paradoxes of the infinite, of the kind that we're now talking about, that, in my view, involve possibilities. In fact, probably none of them. Like, it couldn't be that the Earth and Jupiter have been rotating the sun around the sun forever because they have finite lives, right? I mean, there are various ways that you can pick where you want to put the boundary, like proton decay. In 10 to the 40 years, Jupiter and the Earth are not going to exist, nor is the sun. But once the sun goes red giant, at least the Earth will stop existing. It'll be burned to a crisp. There'll be, right, and that's only 6 billion years from now. If you look back into the past, Jupiter and the Earth and the sun are all about 6 billion years old. Right, so we're talking about a story that's got no connection to reality, no connection to real possibilities at all. Right, in that case, also.
Yes, it really makes sense. Just two more paradoxes. What is the Smullyan's rod paradox?
Okay, so I'm trying to remember this one. So we've got, I think we
Do you
have
want me to help you with?
an infinite rod with a balance point. Is that the way it goes?
Yeah, we have infinite rod and also infinite Earth. Imagine it's flat perfectly. So yeah.
Yeah. And so what's the problem? We balance the rod on something. It can be my finger, I guess, except it can't be my finger because the downwards, right? If we're imagining gravitation, but then you can imagine if the rod's perfectly balanced and you move your finger a little bit this way, well, surely it shouldn't still be perfectly balanced, but it will be, you might think. Move it much further and it's still going to be perfectly balanced because there's an infinite amount on each side, right? I can't remember the details, but I assume that it's something like that. Is that right?
Yeah, that's I think correct.
Right. So we're to imagine that the rod just goes off to infinity in both directions. And yeah, I think, I mean, it's not going to be a problem for me, and I've forgotten what I said about this in the book, but I mean, of course, there can't be such a rod, there can't be such a plane. So I don't think that it really matters what you say in response to this.
Yes, thank you so much. And last paradox, how would you comment on the infinite lottery paradox, which goes like this? Imagine that we have a stack of cards, one with each number, 1, 2, 3, extending infinitely far down. And n days ago, we shuffled the top n cards. So all the cards are shuffled. You and I take a card, each of the top, and the one with the bigger number will win $100. Then
Yeah,
I'm sure your card will win, and you are sure mine will win, and you will pay me a $19.5 to swap. And if I pull the top 100 cards, I will always be sure that the next one will be bigger. That's absurd. So this is a process argument.
yeah. So I think it's true that we can't have um, a uniform sampling from um, an infinite array, like infinitely many balls with numbers from what, you know, for every natural number, there's a ball with that number on it. Um, or tickets, or whatever, right? There are definitely difficulties with thinking through the details of the numbering on the balls and the tickets, because if the balls are of a uniform size, at a certain point, just printing the number of digits on the ball is going to require that the things are so small that we can't read them, right? If we're imagining just using this kind of standard decimal um, system, right? So often when people tell stories like this, they try to get around it by letting it be God who um, determines the numbers, and that God just samples at random from all the natural numbers. And you don't have these problems about if you start thinking seriously about what the tickets or the balls are going to be like, that you start to think that there can't be balls or tickets like that. Um, I'm inclined to think that not even God could randomly select, uniformly sample the natural numbers. That just doesn't, that's not a coherent notion that you do that.
Okay, thank you, Dr. Oppy. Just one more, if you don't mind. I was wondering in a roulette, and we can compare with the gambler's paradox. If, for example, a roulette wheel lands on red 5 times in a row, the gambler thinks now it has to be black, but that's an error. The probability of black is still the same as always because the past outcomes don't affect the next one. So any comment on this?
Um, so the gambler's fallacy is definitely a fallacy, right? Um, so long as we know that the sampling process is uniform, uh, we know that if we run enough trials, we'll get certain kinds of sequences. Like if you're running games of roulette long enough, it will happen that you get red comes up as many times as you like, right? Depending on the number of trials, there'll be a certain probability that you'll get 12 reds in a row, right? And if you run enough trials, it'd be more or less certain that you'll, at least somewhere, you'll have had 12 reds in a row, right? And so long as we don't lose our confidence in the fairness of the roulette wheel, it doesn't matter that 7 reds have come up in a row. That's no reason at all to think that the next one will be black. Of course, we might give a little bit of credence to there's some cheating or something going on, right? But it's not clear how we're going to weigh that. Does that mean it's kind of likely that the next one is going to be red now that we've got 7 in a row? That it's very likely that the next one will be red? Or, right, I mean, once you start adding in hypotheses like that, it doesn't seem to help, doesn't seem to really make any difference to what you should think. Because, I mean, what would make a difference was if you were informed by somebody who you really trusted that the people running the casino had decided to have 13 reds in a row, and you've just witnessed 7 of them, so you might think, well, now I got good reason to go red again. Yeah.
Yes, as I said, I was once in that place, and 10 times in a row it was red, so I quit that.
So, I mean, there are these questions about whether whatever's being used for gambling is fair or not. So there are such things as loaded dice and two-headed coins and things like that. And if you're watching the dice being rolled, and you're checking, you're keeping check of what comes up, you might be able to infer from your data that the dice are probably loaded, right? So it depends on the data, but you need a lot of data to be able to make an inference like that, probably. And we know that a lot of the time dice are not loaded. So they're
Yes,
just things to bear in mind when you're whatever you see when someone rolls some dice. If they've done it just once and they roll 6 dice and they all come up 6, well, and 6 is a good number to roll. Well, that's stuff like that happens, right? If they do it 27 times in a row, then clearly you've got reason to think the dice are loaded, right?
yes, I know some people that works in improving those algorithms, but yeah, that's another topic. But okay, are there any other interesting paradoxes about infinity that we haven't mentioned? One that people don't usually talk about, but are very useful or fascinating to think about? Can you remember any?
So there are some more that are talked about in the Stanford Encyclopedia of Philosophy entry on infinity that I've had a small hand in writing. It's currently co-authored with some other people, including Alan Hayek, Kenny Eastlaron. Um, so is that right? Oh, I can't remember who the co-authors are. That's embarrassing, but anyway. Um, and so we certainly haven't exhausted all of the paradoxes. So there are things like the two envelope paradox, which I think is a paradox about infinity. So I have I have 2 envelopes, and I tell you that one of them contains twice as much money as the other. And then I let you pick one of them. So you're holding one of them. And then I say, do you want to swap? And you should reason as follows. There's a 50% chance that I've got the one with 2x and a 50% chance that I've got the one with x. And so that means that the expectation for swapping is 1.5x. So I should swap, right? Um, But that can't be right, right? You pick the envelope at random, right? It can't possibly be that this argument gives you a reason to swap, because then you could run the argument again and you'd want to swap, and then you'd want to run it again and swap again, right? So something's clearly gone wrong. There are different things that you might say about what's going wrong, but there's actually a kind of tacit assumption in your reasoning, that there's that about infinity, right? I'm not going to try and draw it out, but you're kind of thinking of there being a distribution over the amounts of money that could be in the two envelopes that's not got some finite bound on it. Because, for example, if one of the envelopes contains more than half of all the money in the world, and the other one contains half of that, it's not true that it's equally likely. Is this right? It's not true that it's equally likely that the other envelope contains double what I've got and half what I've got, right? Because if I've got the one that's got more than half the money in the world, it must be that the other one has the half. It can't be equally likely that it's got double. So there's an assumption that was hidden in the reasoning about an assumption that turns out to be false. Right? Like if someone offers to play this game with you, you should just refuse. Right? The St. Petersburg game is another one, right? So the deal this time is we're going to toss a coin. If it comes up heads, I'll give you $1. If it comes up tails, we'll toss again. If it now comes up heads, I'll give you $2. Otherwise, we'll toss again. If it comes up heads, I'll give you $4, else we'll toss again. Now, if you work out what's the expectation here, it's a half of 2 plus a quarter of 4 plus an eighth of 8 plus a 16th of 16 and so on, right? So your expectation when you play the game is infinite. You should be prepared to pay me an infinite amount of money to play this game just once. But that's an absurd result, right? So there's a challenge here to standard decision theory, which maybe is best resolved by noting that as we actually apply decision theory, it's bounded by certain assumptions, like that there's only a finite amount of money in the world. If you offer to play be the banker and give me a chance to play the St. Petersburg game with you, I want to see the proof that you've got an infinite amount of money to pay me on the off chance, unlikely as it is, that we get through infinitely many tosses. Well, of course, we can't do that, right? We'd have to imagine that we've got, the tosses happen quicker and quicker and quicker so that we can get it done in a finite amount of time. There's various problems about the St. Petersburg game, but the idea that you should think that that calculation was a kind of sound way of calculating the value of playing the game once seems problematic. Okay, so that's another example.
Very interesting. I never heard that before. So thank you so much. And how would you comment Alexander Proust when he says the best way to kill all the paradoxes most of which we covered in this interview, is to adopt causal finitism. Infinitely many causes can be behind a single effect. So causal finitism is probably true, but if causal finitism is true, we can't have infinite backwards chains of causes. So he wants to say we have one simple theory which resolves all those paradoxes. So maybe it's good to have one explanation for everything rather than have individual explanation for each paradox. What do you think on this argument?
So some of the paradoxes, so to the two envelope paradox, I don't see how causal finitism is relevant, right? The way that it worked was just, I told you that one envelope had twice as much in it as the other. And then you imagined a distribution, right? So that if one envelope's got $1, the other one's got $2. If one's got $2, the other one's got $4. If one's got $3, the other one's got $6, right? And you didn't imagine at any point that, like, if there's $1 billion in this one, you didn't think, well, it's very unlikely that there's going to be 2 billion in this one. You just had this, right? So there was this kind of infinite distribution, but it had nothing to do with causation, right? So I think maybe I'm missing something, but I think that you couldn't think that absolutely all of the paradoxes that we're talking about could be solved just by appealing to causal finitism.
Yeah, I misrepresented. I wanted to say all that are connected to causal infinities. So maybe Thomson's lamp, gambler's fallacy, I think, what else? Grim Reaper, yeah.
So the gambler's fallacy seems to me a bit more like the two envelope paradox, though. It's not obvious that it's particularly connected to causal finitism. So, but I agree that there's a whole lot of them that are causal. So the Grim Reaper definitely is, the Thomson lamp definitely is. I guess there's a sense in which Al-Ghazali's paradox is causal. But the ones that have to do with your kind of expectations, the ones that have to do with decision theory, I don't think are causal. So that's things like the St. Petersburg game, the two envelope paradox, Pascal's wager.
Yes, and last question, Dr. Oppy, what about temporal finitism? Is that a better theory than causal finitism, or what is it?
Bruce wanted to distinguish between the idea that there's a temporally infinite past and the idea that you could have an actual infinity of causal events put into a finite amount of time, because that's the kind of Grim Reaper structure, and it's the Thomson lamp structure, right? So maybe it's consistent with thinking that you can't cram infinitely many distinct causal bits of causing into a finite amount of time, that you could still have a temporally infinite past, right? And you can get infinitely many causes, but they're spread out over an infinite amount of time. So maybe we can draw a distinction there. I doubt that, I'm sure that Proust thinks that the past is temporally finite as well as causally finite. And maybe he would think that, so I don't know, I've forgotten whether causal finitism is going to lead to temporal finitism, is going to entail it or not. that depends upon your views about the connection between time and cause, between time and causation. But given the way that he's Aristotelian about various things, maybe he thinks that time is the measure of cause or something like that.
Dr. Graham Oppy, thank you for showing us that the concept of infinity opens up a landscape filled with profound philosophical challenges and surprising insights. Dear audience, thank you very much for joining us, and we hope this conversation encourages you to continue exploring the mysteries and the implications of the infinite. For more, follow NT Podcast, like, comment, and subscribe. And until next time, greetings from Serbia and Australia, two completely opposite corners of the world joined together for one conversation. So distance means nothing when the topic is infinite.